All right, so here's a brute force analysis idea. Okay, and we'll pick something that is relatively easy to understand, I think, you know, as far as numbers and how we'll do our simulation and that sort of thing. And so suppose an employer claims it has equality in representation by gender. Now, in this case, I'm not trying to make any sort of political statement or anything like that. I'm just trying to keep things simple. And so by gender, I'm going to say, you know, male, female. And that's so we can flip a coin. It has equality and representation by gender at all levels. Okay, so that's its claim. And, you know, but suppose I look at some mid-level, you know, maybe this is mid-level management or something like that, with a total of, say, 10 persons. And see, now I'm going to go with, I think, typical expectation versus, you know, just something novel. So again, this is just strictly arbitrary, but I'll go with what we, you know, would, I think, tend to see in many situations, and as far as gender and so forth, but it varies, you know. So, but I'll go with, we see 2 female and 8 male. Okay, so like I say, I could have gone with 2 male and 8 female, and it doesn't change the sense of this question. And so the sense of this question is, can we believe, now, you know, some of this becomes wording and what the heck we mean up here by equality and representation, but again, we're going to go with some simplifying assumptions, and you know, so can we believe that these positions were staffed by chance? Because that's the real question here in something like this. Staffed by chance from a general population of 50-50, female, male. Okay, so that's the question is, because again, it's one of these things. Okay, we took this sample of 10 persons and found 2 female, 8 male, and at first look we say, well, heck, that's not equal representation. But again, this is a sample. Maybe this is out of a company of 500, and we're or a company with maybe 500 people at this level, but we don't actually have the numbers. We had to take a sample. And then another aspect of all this is, well, yes, generally speaking, they promote out of a pool of 50-50, but any given day or time, maybe 2 people just retired and 2 people got hired, or they're not hired yet, or something like that, and so, this is just what we happen to see. Okay, and as my grandfather always said, don't wreck a good story with facts. And, so we're just trying to ask this question, that if somebody's claiming 50-50, and we go find these 10 people, just at, we think we've taken a nice random sample, and we find 2 female, 8 male, what do we think? Do we think that that claim of 50-50 is correct, and that it was just by chance we happened to get the 2 and 8? So what could we do? Well, I could flip a coin. Okay, and I'm going to flip a coin 10 times. Now, why do this? 10 people. Okay, and I flip that coin those 10 times, and I record heads and tails, and maybe, a heads that's female, and tails is male. So we have that, and so now here's my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And okay, I flip it, and suppose I got heads and tails and heads and heads and tails and tails and tails, heads and heads. So certainly that could have happened from these, and I count that up, and I see that according to that I had 6 heads and 4 tails. That corresponds to, if we just worry about counting, say, the females, that was 6. Well, that certainly doesn't match the data, right? I had 10 persons, there were only 2 females. And this says, this time when I just went through and just flipped a coin, it said, well, gee, I ought to see 6 females. Okay, now hopefully you get the idea here, right? Is each coin toss gives an equal chance, because it was 50-50, equal chance of getting either a female or a male. And, well, if I really am sampling out of a 50-50 population, but I'm random sampling, well, yeah, I might get 2 heads, then a tails, and then 2 heads, and so forth, just like I did here. And that was 6. But see, if I only do it once, that doesn't really tell me much, because, right, what if I'd gotten 10 heads, or if I'd gotten 10 tails, or something else? I really need to do this lots of times, and And so suppose I do it again, and I get tails, heads, heads, tails, 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 heads, tails, tails, something like that. In this case, I had 3 heads. And I do this, and I do it a whole bunch of times. Then what I could do is keep track. How many times did I get, now I could have gotten as few as 0 heads, right? So how many times did I get 0? How many times did I get 1? How many times did I get 2? 3, 4, 5, 6, 7, 8, 9, and kind of fits there. I'm right at the bottom of the page. So this is heads, and suppose I do this, maybe 100 times each of those, and what I might find is, say something like, out of those 100 times, maybe 20 of the times I got 5, and I'm going to just use some very simple numbers. What am I up to? Up to 50 out of the 100. What if I do 10 and 10 like that? Now I'm up to 70, and yeah, so let me change these numbers a little bit. Let me go with 25 here, 20, 20. Now I'm up to 65 there. If I do 15 and 15. Now in real life, I probably wouldn't get these numbers that just look so nice and so similar to each other with nice symmetry and so forth, but they'd be something kind of like this. So what am I up to here? I've got 30 and another 40. I think I have 95 of them here, and so I only have about 5 left. So let's put 2 there, 1 there, 2 down here at the 8, and 0 and 0. And there I have a total of 100 of these things. Now, if I look at this, I was wondering how often would I get as few as 2, because here are the data, right? The data are that there were 2 females, so this is my frequency. Okay, so my data, so if we think back to the overview of this thing, we have a claim of 50-50. Okay, so that was our claim. Then we assume that claim. And that's where I used a fair coin 10 times. And then we ask, could we get our data? Right? Could we match the claim? And we look here, and actually we matched it 3 times. Now you'll say, wait a minute, that's the only time we matched it, that was 2. Yeah, but this is even more extreme out here than our data. So if we decided it wasn't weird to have just 1 female and 9 males, if we thought that was fine as far as our claim, assuming the claim and seeing if we could match it, then that's actually in some ways better than the 2. You know, it says, hey, we could even see just 1. Sure, we could see 0. We didn't in this little fake simulation I did here, but so we're looking at this, and we want to look everywhere that was at least as extreme as our data. And so our data said 2, and so we'll look at 1 and 0. Now, I don't want to confuse matters to begin with, but we could also ask in the other direction, and we'll talk about one-sided and two-sided things later. But for now, we'll just look at this one side, is that, you know, we look here, and could we match this claim? And we could 3 out of 100 times. Okay, so what do we think? Well, our answer then is essentially we reject the claim. Now why? Well, because it didn't happen often enough. Okay, it only happened 3 out of 100, and in this class, generally speaking, for most everything we do, for us to decide it happened often enough that we could say we could match it, it needs to happen more than 5 out of 100 times. Okay, more than 5% of the time. So in this case, we're going to say, nah, we reject that claim. We don't believe it, okay, because it's too rare. We're not that lucky, right? We wouldn't get a sample that only happens 3 out of 100 times. So it can happen, that's the point, it can happen. But it doesn't happen often enough. We're going to say that our little experiment here did not support this claim. Okay, so we had to reject that claim. All right, I'm pausing to let you in the video kind of think about that a minute. Right, but here's that big picture. Somebody made a claim. We assumed that claim, right? How did we assume it? We used a fair coin, which is 50-50, and we threw it 10 times to count for each one of those 10 persons. And then we asked, well, how often would we get what we see in that office space or wherever we did this? However we did it, you know, how often would we see just 2 or fewer females out of 10 workers? And here, when we did this simulation 100 times, we're saying, oh, well, we only saw it 3 out of 100 times, and so that's not often enough. Now, you know, was 100 enough times doing this? Well, in class for our project and so forth, we're going to do things 1,000 times. And by the time you get to 1,000, that's pretty good. 100, actually 100 can be a little small at times for doing this kind of an investigation. But it made it easy to do percent, right? So if I do 100 and I go with 3 out of 100, that's 3%, and that's smaller than our 5% or 0.05. So in that case, we would say, hey, our investigation, our statistical investigation, which was running these numbers, getting these frequencies here, our statistical investigation determined that if this claim were actually true, we would only expect to see 2 or fewer females about 3% of the time. And therefore, we don't think that claim is true. We think it must be something different, and most likely that it's they're pulling, they're not really pulling from a population that's 50% female and male. It probably means they're actually fewer females than males if we go with this. But we don't really know. I mean, that would be the logical thing to come up with here, is it's probably fewer. But then we might do some more studies to try to get a better handle on what exactly that is. We will look later in this chapter about how we would make a guess. Our best guess actually would be our data, our 2 out of 10, or about 20% female, 80% male. But we need more than that. We can't just claim the 20 and 80. We need to say a little more than that. Okay, so again, here's just one example. Click that. Where we tried this brute force idea. We have this employer claiming basically they're pulling people from a pool of 50-50. We go in and sample. We find 2 out of 10 female, 8 out of 10 male. And so we want to ask, well, do we still believe them with the 50-50? And so we set out to try it. We flip a whole bunch of coins over and over and over again. And after, we did 10 coins 100 times, so after 1,000 coin flips, we decide that, no, we don't think that they really came from this population, because if we use that population, we can't really reproduce their data very well. We only reproduce their data about 3 out of 100 times. Okay, and that's our data, and so we're going to reject their claim and say that that our data, our work, does not support their claim. Our data of 2 out of 10 female doesn't support their claim of 50-50. Okie doke. So there's our first example.